Page 2 says graph this piecewise defined function. So it is y equal 3 minus x. So if I got to put numbers less than -1. So if I put in -5, 3 minus a minus 5 is 8. 1, 2, 3, 4, 5, 6, 7, 8. 3 minus -4 is -7, because minus a minus is plus, and then -3. 3 minus a minus 3 is 6. 3 minus a minus 2 is 5. 3 minus a minus 1, and I can't do that one, but up to that one. So it's going to be a line coming in like that, going on that direction. And this is 1, 2, 3, 4. Now y equals x plus 2 is a line, and we're supposed to do that from -1 to 4. So I'll put in -1 and I'll get 1. And a solid dot. Put in 0 and I'll get 2, 3, 4, and when I put in 4 I get 6. 5, 6. When I put in 4, I get 6. There it is right there. So it's two separate lines. List the intercepts. Only one. 0, 2. Z of -5. If I put -5 in, I would use this one. 3 minus -5 is 8. And of 2, I get 4. 2 would go into this one. 2 plus 2 is 4. 6. So g minus k of x. G is x plus 1 minus k is x plus 5, and we have to distribute the minus, so we get x minus x, which is 0, and 1 minus 5 is -4. Turns out to be just a number, not a function. No x in it. B, f of g of -4. So this is times, not f of g, but f times g. So we're going to put -4 into both of them, into g, and also into f. This is not an open circle, it's a closed circle. So we're going to multiply the answer of f of -4 times g of -4. And f of -4 is 16 plus 8, 24, times g of -4 is -3, so we get -72. This says f of h of x, so we've got to, it's going to be of x, so we've got to put h of x, this square root thing, into f. So so it's going to be f of square root of 3x minus 2. So now I got to replace all the x's of f, the x squared, with the square root of 3x minus 2 minus 2 times x, which is the square root of 3x minus 2. This would be 3x minus 2 in absolute value, the square of something squared. This would make it positive, squaring makes it positive, so there, minus 2 square root of 3x minus 2. Find the domain of k of h of x. K of h of x. Well, k can take anything because it's x plus 5. But what you can put into h, this would have to be a positive number or 0. So we'd have to do 3x minus 2 and make sure that's greater than or equal to 0. So we'd add 2 and divide by 3, and x has to be greater than or equal to 2/3. And this would be the domain of h of k of x. H inverse. So we're going to swap y and x. So h of x will become just x, and the square root becomes 3y minus 2. And we solve for y, so we square both sides. We get x squared equals 3y minus 2. Then we'll add 2 and then divide by 3. So we're going to get x squared plus 2 all divided by 3 is h inverse of x. Determine the domain and range of h inverse of x. Well, let's go back and look at h of x. H of x is this square root that had to be from 2/3 and on. The square root, no. So if we put in 2/3, we get 0. And then if you graph that, you'll see that it goes something like this. Its inverse would be something that looks like this, half of a parabola. So this, which is 1/3 x squared plus 2/3, so it's a parabola that's pushed up to 2/3, and it's 1/3 as tall. So the domain and range of the inverse. The domain would be for x has to be greater than or equal to 0. That's x has to be positive in the inverse. And the range is from greater than or equal to 2/3. Oop, I didn't show all that there. Let's do that again here. So if you graph f, which was the square root of 3x minus 2, it looks like this, and you can do it on your calculator if you want. So the inverse, which is a reflection over the y equal x, looks like this. This is half a parabola, this is half a parabola, this is a sideways parabola. So if you look at the original inverse, which is this is 1/3 of x squared plus 2/3. So this is the h inverse of x. But we only want this half of the parabola, so the domain has to be the positive x's from 0 on of this for the inverse of this to match this. You don't get this half because you don't get this half of the square root. And the range, it starts from the bottom of that parabola up. Well, this is a parabola that's moved up to 2/3, so that's the range.